This is a rocket ship, and this is a rocket trying to be a race car. Race cars have masqueraded as rockets in the past, but today we're going to be taking rockets and then engineering them into race cars. This is the second time ever that I've played Kerbal Space Program. However, my journey started in an entirely different universe where I was engineering dinosaur enclosures, not race cars. I was working on the enclosure for a new mosasaurus when I realized something. Oh my gosh, I go back to college in a month and I haven't done any automotive engineering work this summer. I'm on a race team that engineers a formula car during the school year, and I hadn't done any prep work at all this summer. I need to do something to prove to myself that I'm ready to help our team win this next season. I needed to practice, but I also needed to make a YouTube video. I heard about a race car competition in this aerospace engineering game. Apparently, there's a world record for the fastest land speed on Earth. If I can set the new record, that will be the proof that I'm ready to get back to automotive computer engineering in the fall. I mean, I may not have played this game before, but I've literally built a formula car. How hard can this video game be? Guys, it turns out it's really hard. And that's because this game is one of the most complex spaceship engineering games out there. I mean, even NASA uses it sometimes. Anyways, there are so many physics that are taken into account, and the depth of the game even boggled my mind. It's tutorial time.
Welcome to today's lecture on vessel construction. I'm Werner von Kerben. Oh, look at that. There's a fuel tank going along the back. Oh, and some boosters. Aha! Wow, that's a weird noise. Sounds like a villager from Minecraft if he was on crack. Learn the basics of flying a spacecraft in KSP. Oh yeah, we're sending it. Training. Intermediate construction. We're almost there and you're doing fine. Maybe not as speedily as someone of my caliber though. Okay, Mr. Werner von Kerm. Suborbital flight. Well, isn't this kind of sick? Alright, let's go for orbit. Dude, these Kerbals sound so weird. I did not mean to... Yeah, did not mean to We're in orbiting 101.
I finished the tutorials, and now that I understand the game a little bit better, it's time to build a race car.
Welcome to the space plane hangar. We want to grab a cockpit. Oh, and then we have fuel tanks here. Structural. Okay, so we actually have structural pieces. Aerodynamics. Oh, this is good. Ground. You got some landing gear. Electrical stuff. And utility. A crew section. Can we rename him? Jebediah Kerman. Oh, we're gonna have to name this. Race car 1. Delta V values. Body, Kerbin, altitude, vacuum, start mass, end mass, engineers reports. Oh, this is what I'm gonna be doing. Alright, well, let's get building. We need a fuel tank, I think. Mark 1 liquid fuel fuselage. Oh, yeah, right here. Alright, now we need some aerodynamics. Tail fin. Nope, too big. One of these suckers right here. Let's put it on top. It's a little bit crooked. Ooh, toggle snap, aerodynamic overlay. Oh, this is great. We want one of these. Is that it? That looks like it's it. Okay, now we need some wheels. Do we want steerable? We want one steerable in the front. A little bit confused as to why I have two of them, but we'll just put them right here. And this looks like it could run okay. Aerodynamic overlay. Oh, it's going up, okay. This thing's gonna fly. It's gonna literally lift so fast. Can we turn and burn? Oh, there we go. Oh, stay straight. Catastrophic failure. Jebediah Nope, no. Black that out. Jebediah was not killed. No, if we just press Z, space, yep. We're off. Alright, kill it. 200 meters per second, but we didn't manage to survive. So let's see if we can build a car that will survive. We need some liquid fuel engines, so we're gonna need a fuel tank.
This would be a good time to mention a couple of the challenge rules that we will be attempting. First off is that your primary method of thrust has to be through liquid fuels. No nuclear reactors or solid fuels. Second, we have to stay on the runway the entire time. Third, our spacecraft can't fall apart at all. And fourth and lastly, we must stay on the runway. We can't go off the end.
And now let's just get a good thruster. Okay, thrust 15,000 kilonewtons. 16,000 kilonewtons. We're looking at the top number because that's, we're not in a vacuum. Alright, we're just going to grab this one for now. I want steerable on the front, right there. Now I want some aero. Okay, so we can toggle the aerodynamic overlay. Thrust up. No, I don't want thrust up. Okay, what if we turn off toggle snap? What if we turn off this? Turn off everything. Just let me orient this how I want it to. We're gonna have to experiment with some of these tools, aren't we? So if we put the arrow in front of the center of mass, the car's gonna flip back. If we put it behind, the car should stay down. Center of arrow is right here, and we have no lift, but we do have stability now, which is good, because we need stability. Oh, there we go. That is some downforce. This is what we want. We want as much of this as possible.
Downforce is an important calculation for any sort of race car engineer. It helps affect how well the car is able to stick to the track and turn around tight corners at high speeds. A Formula 1 car makes over 1,500 pounds of downforce at 100 miles per hour, which is more than its weight. Downforce is a type of a force vector, so it's measured in newtons. The equation to measure downforce is 0.5 times the surface area times an aerodynamic coefficient times the air density times speed squared. If we really wanted to, we could use this equation to calculate all of our downforce in Kerbal Space Program. However, that wouldn't be entertaining, and I don't have the time to do it, so we're just going to use trial and error.
You see this blue line? This is which way the aerodynamics are forcing our race car. So we have a stability fin in the back, 2 small aero pieces in the back for downforce. We want some, ideally we'll have some more in the front, but I think this will be okay to start off with. Why is it going forward? Do we have some wind? Is there wind around here moving us forward? Max throttle, 3, 2, 1, go. Oxidizer deprived. Oh, we don't have any oxidizer. Never mind. We have something that holds oxidizer.
Automotive engines need 3 things to run: spark, fuel, and oxygen. The fuel and oxygen combine, and the spark ignites them. In space, rockets need the same type of combination, but there's no oxygen in space, so they have to carry their own oxidizers, which releases oxygen to mix with the fuel and combust.
Yeah, delete you. Put you back. It's alright, we're gonna save this. It says it has no command modules. Cockpit. Include a pilot. Yeah, you're coming with me. All you guys are coming with me. Missing in action, Rip Jebediah. Alright, it's leaning a little bit forward. I think it starts perfectly flat, so when it leans forward, it gains a little bit of momentum, which is really interesting that they take the little bit of potential energy and convert it into kinetic energy. Go. Alright, we're just gonna see how fast we can go. You know, that was not awful. I think we need more downforce. To do that, we're gonna need some more stages. Alright, now we're gonna add some more downforce, I think. So we need some bigger wings for downforce because it's clearly not producing enough. Okay, these look like they'll work. Do I get any information on the aerodynamic overlay? Like, is there a spot that it tells me the calculations? Wing area, 0.5. There's 95% of it is immovable, 5% of it is movable. We're actually going to be able to control the downforce here, so we can push this thing into the ground. Whoa! Bro did a Tokyo drift. Holy! Send it. Yep. Down. You know, it might be too much downforce, honestly. And we're going to try to toggle them up. Nope. Again. If it starts shaking, we're going to throttle down. Bro, what are you doing? Come on. No. Dang it. Valentina Kerman paid a noble sacrifice to the cause. It seems to be the fixed landing gear, so I wonder if we can make like a sled instead. Listen, if we have to steer, you're doing it wrong, okay? Let's go to gear. It's gonna be like a sled. All right, try save and launch this. You know, there is a good chance we're just gonna go head over kilter straight forward. Let's send it. Wait. I think we're onto something. Nope, we're not. We're not onto something. We lost Valentina for the 4th time. Now this looks like the most promising attempt that we've had so far. Got some good downforce on the sides. 3, 2, 1, go. Go. It's just turning so fast. I think we're gonna solve this by making a wider vehicle. We can't have no jettison parts and no clamps, no welding, unbreakable joints, or any anti-vehicle shattering mod. Structural fuselage. That's what we need. All right, we're gonna grab some more of these steerable landing gears. You know, this is very different than building a car that has a literal motor inside of it instead of one of these rocket boosters.
Automotive engineering is very different from spaceship engineering in that there's different subsystems that you work with. Automotive engineering has 6 different main subsystems, and each subsystem has engineers that work together. There's aerodynamics, braking, frame and ergonomics, steering and suspension, electronics and control systems, and the powertrain.
2, 1, turn on SAS. Yeah, a little bit left. No, go! Over 203 meters per second. That's progress. All right, we do need a controllable rudder. Found lying at the side of the road. Sounds about what we get our parts for our formula car from. Once we figure out how to get to the end of the runway, we'll worry about slowing down. Go. Oh yeah, much better steering. Oh, I overcorrected. It's all right. I have a good feeling about this. Throttle up. Okay, that was a huge success. We made it the whole way to the end of that runway. Now we need to go figure out how to go faster. And we're gonna use some math to do that.
I looked up some stuff and ran the engineering calculations after I recorded this video to see what the theoretical numbers would be. The length of the Kerbal runway is approximately 2,500 meters long, and our goal is to reach a speed of 500 meters per second. Now, if we were at this speed the whole time, that would give us 5 seconds down the runway, which means that in order to accelerate to this speed by the end of the runway, without any braking, we would need to go at 100 meters per second squared of acceleration. Thrust is in newtons, which is mass times acceleration, and our engine produces 936.508 kilonewtons of thrust, and it weighs 4 metric tons. Now, we just solved the equation for the theoretical mass that our ship could have. It ends up being about 9,365 grams, or 9.365 metric tons. This is in a perfect environment with no friction and no wind resistance.
Well, I think that the correct method would be to do some complex calculations and then figure out the ideal mass to thrust ratio of this vehicle. I don't know that Kerbal has all of that super detail. Also, this car is floating. But anyways, what we're going to do is we're going to grab the most lightweight cockpit. I think it's going to be this Mark 1 command pod. Here we go. I have a suspicion that the rock is tipping slightly forward, which would cause the thrust to be pushing slightly up, and that might be what we're seeing the resulting nosedive. So, to combat that, we're just gonna move the whole entire plane forward and add some more weight in the front to try to move the center of mass. We're gonna name this one Max. 3, 2, 1, and we're off. We're not allowed to leave the runway at any point. 381. Holy crap. I bet we can get it. 3, 2, 1. I think the problem is we're drifting too much from side to side. I think that the wheels need to be directly under the car. All right, this already looks more promising. It's not bouncing around like it was before. Highest speed was 613, 612 over land. That's really good. I think the solution is that we've been doing this all wrong all along. Because really, all you need is a little bit of aerodynamics nose cone, a fuselage piece, another fuselage piece, and grab yourself a pair of these Rove Max rugged wheels. Because then all you gotta do is try to drive and realize that your craft is touching the ground and your wheels aren't doing anything. And then you ask yourself at the end of the day, why did I decide to try to do this? Oh yeah, we're really picking up speed now. We're about to hit supersonic. Alright, we're remotivated. We need to figure out how in the world to keep going straight, even when it's really quite difficult with these wheels. This is something that I saw helped as well, moving the wheels into the craft for a lower center of gravity. Alright, we can easily make it to 250. So let's figure out a braking system.
When it comes to how traditional race car brakes work, it's all about pneumatics. When you're pressing down on a brake in your car, you're putting pressure into a small fluid line. This line then applies the pressure over a wider area at the brake calipers, which means that it's more pressure applied, which has the power to stop the brakes and stop your car.
Now, the system that I saw them using was almost like a drag chute system, except it utilized these Elvons, I think, Elvon 4. We've got to run some scientific tests to see if this works. So throttle's going to go up to 1/3. We're going to send it. Alright, that's pretty good. And now, oh, it does do something. The one on the bottom and the one on the right exploded, so it's slowing us down less. You know, I think if we had enough of these, it could work. We kill it, hit the lights. Oh, it gives it lift. If we don't have the ones underneath, it gives it lift. We go. Kill the throttle. Toggle the lights. Well, I mean, it kind of worked. Send it. Stop it. That was pretty good. Ah. I think the problem is that there's no wheels behind this, so it has nothing to lean back on when it's braking. So to solve this, we're gonna grab a long strut boy, and we're gonna put wheels underneath it. Some of these small wheels. Oh yeah, that's what we needed. We hit 287. I think we can go longer.
I was about to make the ultimate attempt for my world record. All of the work that I had put in so far was culminating to this one run. Would I be able to break 500 meters per second? Or would I fail, proving that I wasn't ready for the automotive engineering coming in the fall?
3, 2, 1, go. We're gonna stop braking right around here. Come on. That might have been our best run yet. 366. Not gonna put us in first, but it'll put us in the top 10.
Even though I failed, I learned and adjusted over and over again with the engineering method. I put the knowledge that I had to good use and never gave up, and this is what engineering is really all about. Sure, I might still have some more studying to do before the fall when I work on an actual race car, but I think that this is a good starting point, and perhaps in a future video, I might be able to reattempt the world record.